Welcome to my dear student, fourth year honors discrete mathematics class. Today I will discuss logics. First we will know the definition of proposition. Proposition. A proposition is a declarative sentence which is true or false but not both. A proposition is declarative sentence. That is true or false but not both. Examples: Dhaka is a capital of Bangladesh. This is a declarative sentence. The sentence is called proposition. Example 2, 1 plus 1 equal to 2. This is also a proposition. Number 3, 2 plus 2 equal to 3. This is also a proposition, but this proposition is false. Now we will know the definition of compound proposition. Compound proposition. Mathematical statement constructed by combining one or more proposition is called compound proposition. Mathematical statement is constructed by combining one or more proposition. Is called compound proposition. Compound proposition. Now we will know negation of proposition. Negation. It is called negative proposition. Let P be proposition, then negation of P is false of P. False of P. It is denoted by negation of P or negative of P. Truth table. Negation of truth table. Now we will know negation of truth table. let P is true, the negation of P is false, and P is false, the negation of P is true. Now we will learn the definition of conjunction. Conjunction. Let P and Q be proposition. Let P and Q be proposition. Then the proposition P and Q is denoted P conjunction Q is the proposition that is true. When P and Q are true. Otherwise false. Now we will see the truth table of conjunction. Truth table. Let P and Q be the proposition. Let P and Q be the proposition when P is true and Q is true. P is true, Q is false. P is false, Q is true. P is false, Q is false. Then P conjunction Q is true. When P is true and Q is true, then the P and Q is also true. P conjunction Q also true. Otherwise false. তাহলে we can say that P and Q also true, then P conjunction Q is true. Otherwise P conjunction Q is false. Now we know that disjunction. About disjunction. Let P and Q be the proposition, then the conjunction P, then the disjunction P disjunction Q is also false when P and Q both false, otherwise true. Let P and Q be proposition. The the disjunction P disjunction Q is the proposition. Is the proposition that is false. That is false when P and Q are false. Otherwise true. Now we can see the truth table of disjunction. P and Q be the proposition true, true, false, false. True, false, true, false. P disjunction Q, when P and Q false, then P disjunction Q false, otherwise true. Now we know about exclusive. 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 Let P and Q be proposition then the exclusive of P and Q denoted P exclusive Q is the proposition. Is the proposition that is true when exactly one of P and Q is true. Otherwise false. Now we will see the truth table. Let P and Q be proposition true, true, false, false. Q true, false, true, false. P exclusive Q true, true, false, false. P exclusive Q is true when exactly one of P and Q is true, then P exclusive Q is also true, otherwise false. Now we will know about implication. Implication. The implication P implies Q. The implication P implies Q is also proposition. That is false when P is true and Q is false. Otherwise true. Now we know the truth table of implication. Let P and Q be the proposition, then the implication of truth table is T F F T F T F Q. P implies Q is false when P is true, Q is false. Then P implies Q is false, otherwise true. Now we will know the definition of a contradiction. Contradiction. A compound proposition is always false, is called contradiction. Now we know the truth table of contradiction. P true, false. Negative P false, true. Then P conjunction negative P false, false. Then the example of contradiction, that is P conjunction negative of P, P conjunction negative of P is the example of contradiction. Now we know that the definition of tautology. T-A-U, tautology. When the compound proposition is always true, then the proposition is called tautology. Now we will know the truth table of tautology. Let P be the proposition. Let P be the proposition. Negative P, true, false, false, true. P disjunction negative P, true, true. Now we can see that P disjunction negative P is the example of tautology. That is when the proposition, compound proposition is always true, is called tautology. Now we can solve some problem. Problem 1. So that P conjunction Q, P conjunction Q, conjunction negative of P disjunction Q, P disjunction Q negative, P conjunction Q, conjunction negative of P disjunction Q. এত is contradiction. Let P and Q be the proposition. True, true, false, false. True, false, true, false. P conjunction Q, P conjunction Q, true, false, 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 false. P is disjunction Q, P disjunction Q, false, true, true, true. Negative of P disjunction Q, false, false, true, false, 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 true. Then P conjunction Q, conjunction negative P disjunction Q, false, 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 false. Then we can conclude that P conjunction Q, conjunction negative P disjunction Q is always false. Then it represents contradiction. We can solve another problem. Problem 2. So that negative P disjunction Q disjunction P is tautology. Let P and Q be the proposition. Let P and Q be the proposition. True, true, false, false. True, false, true, false. Negative P, false, false, true, true. Q disjunction P, false, true, true, true. Then negative P disjunction Q disjunction P, true, 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 true. Then we can see that final value of negative P disjunction Q disjunction P, negative P disjunction Q disjunction P is final value is always true. Then the proposition represents a tautology. Thank you, my dear student. Next class we will solve another sum problem. See you again.